All right, let's jump right in. We are looking at a really fascinating study today that pits artificial intelligence against one of the biggest challenges in the energy world, trying to predict what happens during hydraulic fracturing. It's basically machine versus rock, and honestly, the results are pretty incredible.
So think about this for a second. How on earth do you predict the exact shape of a crack that's forming a mile beneath your feet? You're blasting this rock with high-pressure fluid, and you're essentially blind. It is a wildly complex problem, and getting it wrong can cost a fortune.
And that's why we're calling this whole thing the underground puzzle. You know, for decades, engineers have been using these physics-based models to try and solve it. But with so many hidden variables, so many unknowns down there, getting a truly accurate prediction has been next to impossible.
Now, just to make sure we're all on the same page here, what is hydraulic fracturing, or fracking? Well, the easiest way to think about it is that you're creating these tiny little highways deep inside the rock. You pump fluid down at these immense pressures. It cracks the rock open, and that gives all the trapped oil and gas an easy path to flow out.
The whole thing happens in 4 main stages. First, you've got perforation, where you punch little holes to get things started. Then comes the injection. That's the high-pressure fluid that creates the cracks. And this next part is absolutely crucial. You inject a proppant, which is usually just sand, to prop those new highways open so they don't slam shut. Finally, you get the fluid out of there, and you're good to go. So yeah, the process itself sounds pretty straightforward, right? But predicting the outcome? That is a whole different ballgame. All those underground uncertainties turn it into a super expensive guessing game. One wrong move, and you could be wasting millions of dollars.
And this is where this new study just completely flips the script. Instead of trying to perfectly model all that complicated physics, which, let's be honest, is nearly impossible, the researchers asked a different question. What if we just let the data tell us the answer? This is a huge shift from a physics-first to a data-first way of thinking.
And when I say data, I mean a lot of data. We're talking about a massive data set with over 16,000 different records. For machine learning, that kind of scale is an absolute game changer. It gives the AI enough examples to start seeing these tiny, subtle patterns in the rock that a human or even a traditional computer model would totally miss.
Now, the AI wasn't just fed a bunch of random numbers. It was trained on 4 super important physics-based parameters that engineers already use. Things like how thick the fluid is, the height and length of the crack you create, and how long you pump the fluid for. This keeps the AI's predictions grounded in real-world engineering. Okay, so the data's ready, the parameters are set. The researchers decided to set up a competition. They wanted to find out once and for all which type of AI is the absolute best for solving this underground puzzle. It was a true machine learning showdown.
3 different, well-known algorithms were thrown into the ring. Each one has a totally different way of looking at the data, a different way of trying to find that perfect recipe for predicting what's going to happen.
So first up in the ring, you've got the neural network. It's actually inspired by the human brain, and it's amazing at finding really complex hidden patterns in data. And in the other corner, you have random forest. The best way to think about this one is like you're asking a committee of hundreds of different experts for their opinion, and then averaging all their answers together to get one super reliable prediction.
And the third and final competitor was the support vector machine, or SVM for short. This algorithm is all about efficiency. Its whole goal is to find the single best, clearest dividing line to separate different outcomes in the data. It's a real master of classification.
So there you have it. 3 powerful algorithms, 1 massive data set. The stage was set. After all the tests were run, it was finally time to see who came out on top. Time to crown the champion. And here are the results. This chart shows the final accuracy using a metric called an R-squared score. Just think of it like a grade on a test from 0 to 1. A 1 would be a perfect A+. And as you can see, all 3 models did incredibly well. They're way up there. But in machine learning, even those tiny differences at the top matter. And there is a very clear winner.
The winner, by a pretty solid margin, was random forest. It scored an incredible 0.9804. I mean, that is just astonishingly close to a perfect score. What this tells us is that for a chaotic problem like this one, with so many hidden variables, that wisdom of the crowd approach from random forest is just flat out more reliable.
And let's take a closer look at the winner's scorecard here. It's not just that amazing accuracy score. Its error rates were also the lowest. These other scores, MAD and RMSE, they basically measure how big the model's mistakes are on average. And just like in golf, the lower the number, the better. This proves the model isn't just accurate,
It's consistently accurate.
And what's really cool is that the researchers didn't just stop there. They tested all kinds of conditions and found the absolute sweet spot for the model. It hit its peak performance when they trained it on 80% of the data and then tested it on the 20% it had never seen before. That kind of thoroughness just proves how stable and reliable this model really is.
Okay, so what does this all actually mean for the real world? We've seen the problem, we've seen the data-driven solution, and we have a clear winner. So let's talk about what the future of fracking could look like with this kind of predictive power.
I mean, you don't even have to take my word for it. The authors of the study said it perfectly themselves. This isn't just some interesting academic experiment. They built a practical tool that could be put to use in the field right now, especially in those really complex geological areas where you have a ton of data to work with.
So, to wrap up, let's just recap the huge breakthroughs from this study. They showed that when you combine a massive data set with solid engineering principles, you can create a hyper-accurate predictive model. They found the most stable way to train it, and they proved, systematically, that for this specific job, random forest is the undisputed champion. All of this leads to one final, really mind-blowing question. We now know that AI can predict these outcomes with almost perfect accuracy. So what's the next step? Could an AI like this one day be plugged directly into drilling systems, guiding the operation and making adjustments in real time, a mile underground? It really feels like the line between science fiction and everyday engineering is getting blurrier by the day.